let's just have some simple review. Rotating a mirror keeping the direction of the incident ray constant. Okay, just let's look at some simple review on this idea here that when we're rotating a mirror, but in all that we keep the direction of the incident ray constant. What do you think happens? We look at review and then try to look at its application. So if we consider our plane mirror, if I consider my plane mirror like this in position M, and now if I draw here the normal, and now it so happens that this is my incident ray, this is incident ray, and then it is reflected in this direction here. If this is A or any, we say that this one can be, I can call it R. And then if it so happens that I now decide now to rotate this mirror to come in this position here. Initially it was in this position horizontally, but I'm rotating it to come in position M1, such that now the reflected is now in this direction here. I can call R1, such that now the shift from the first position to this position, I can call it maybe say X. Okay? And then I can say initially this is the angle of glancing G. Is that okay? And now this one here, this angle here will act as our angle of deviation D1. Like initially, when we're in the first position here of the mirror, the angle of glancing was this, and now the ray was reflected in this other direction R, and then the angle of deviation, I'm calling it D1. Now, supposing it was rotated through an angle theta, okay? Now, the reflected ray is now going to move in position or R1. So I can say this is the new angle of deviation, this one here, okay? And I can call it D2. Is that okay? The deviation as a result of now rotating the mirror in this other position here, so that as the ray is coming, it is now reflected in the other direction. So the change in direction, I will call it D2 or deviation 2 as a result of rotating the mirror through angle theta. So let's look at the relationship between theta and X, where X is the shift in the reflected ray. That initially the ray was in this direction, but later on it is in the other direction. So what is true about our D1? What is deviation in the first case? Remember we looked at deviation equal to twice angle of glancing. So if the mirror is still in this position here, the angle of glancing we said is G, and deviation D1 will be equal to twice G. And then also if we look at case 2, when the mirror has been now rotated in the second position, that means our angle of glancing is now this. This is the new angle of glancing, the angle between the incident ray and the mirror or the reflecting surface. So if the mirror comes here, that means that the angle of glancing now will be G plus theta. That means that in this case here, D2, which is the angle of glancing, will be equal to twice G plus theta. Is that okay? And now remember we said that we are interested in deriving the relationship between the X and theta, so that we see its application ahead there. So if that is the case, we are going to say that what here is very true is that x is equaling to, what is this angle x here? It is the same as d2 minus d2 minus d1. It will be d2 minus d1, and x will be equaling to, my d2 is from equation 2 is twice g plus theta minus d1 is twice g, and then I think x here can be equal to twice g plus twice theta minus twice g, and x equaling to twice theta. This is what I wanted us to remind ourselves about, such that we look at the application. How do we apply it in instruments, some of the instruments? So, and this is now going to work as our principle, that if light rays is, if the source of the light ray is maintained constant or is maintained in a given position, the reflected ray is always rotated or shifts at an angle which is twice the angle of rotation of the mirror. Is that okay? So we are going to use that one as our principle in the instrument that we are going to look at. So let's look at that instrument after reminding ourselves. The application of this principle of stating that keeping the source of the light constant but rotating the mirror makes the reflected ray to shift through an angle twice the angle of rotation of the mirror. So number one, let's look at the sextant. A sextant. What is a sextant? A sextant is a device that is used to determine the angle of elevation of heavenly bodies, e.g. the sun and the star would be our example. Is that okay? So we are saying that what we are calling a sextant, it is just a device or an instrument that we always use in determining the angle of elevation of heavenly bodies. Is that okay? What is angle of elevation? First of all, if we can ask ourselves, what is an angle of elevation? An angle of elevation is, I could say in simple understanding, it is the angle between our line of sight and an instrument and an object above the line of sight. What do I mean by line of sight? If you have your eye here, the line that is horizontally to your eye level is what we are calling the line of sight. If you stand, and then the line which is in this line, the line that is in this level of your eye is what we are calling the line of sight. And then if you so happen, from your line of sight, and then you raise your head up to look at something from above, we call that one angle of elevation. Imagine you have a body here that you want to look at, and now you raise your eye up here. You happen to raise your eye in this, you want to see that, and then you raise your eye here. This is what you're calling the angle of elevation. Is that okay? So we use the sextant to determine angle of elevation of the sun. That is when the sun is above. Okay? The line of sight. Don't confuse it with the angle of depression when you put your eyes below to look at something down. From the line of sight, you see down. That is angle of depression. This is angle of elevation. Is that okay? So, we are saying that a sextant is a device that is used to determine the angle of elevation of heavenly body. And basically here we can look at the sun and the star. Okay? So, now, what is the structure of this, or how does it look like? The main important parts.
This you want?
So we say it consists of a fixed. It consists of a fixed half silvered mirror and half silvered mirror, and then a mirror fully silvered. Let me call it fully silvered mirror. A fully silvered mirror which is free to rotate, and a telescope. If we are talking about the structure of this instrument here. So, how do we draw it? We said already we have a half silvered mirror. Is that okay? A mirror whose half of the length is not silver, that means you can see through, and then half is silver. And then also we said it is also having a, let me draw it here. This is half silver, and then I have this one here. This one is the one which is the fully silvered. This one I can call it mirror M, and then this one I can call it M1. Is that okay? So I can now look at having my telescope here. This is my telescope where I will make observation from. I have a telescope there, and then I can set a reference horizon. I can call it H, and now from here I can have this, and now I set another horizon to this H prime, and then I look at a scenario where maybe I'm going to determine the angle of elevation of the sun. Now supposing the mirror is rotated in this other position here, such that now the ray is just like that. So this mirror can be now in position M2. Is that okay? This will be M1. This is M2. And now I have decided to rotate it. I've decided to rotate it through some angle I can call theta. That is how I can maybe draw my simple structure of a sexy tent. Is that okay? We have talked of the parts. We said it consists of a fixed half silvered mirror. This is the half silvered and it is fixed. It does not rotate. Is that okay? This is the mirror I'm meaning. And then we also have the fully silvered. This one is silvered fully. The hollow length is silvered and it is free to rotate. Is that okay? And this is my telescope that I'm talking about. This is the telescope. This is a half silvered mirror, and then this is the fully silvered mirror. That is my sun, and then these are the horizons. These are horizons, levels that we are setting in the atmosphere as a reference point for us. Is that okay? And then let's look at the operation. Mode of operation. How does it perform its function of determining the angle of elevation of this heavenly body? An example here is now the sun. That is now what we are going to look at. So we are going to say, light rays, the mirror M1 the mirror, should I call it a fixed rotating mirror? The movable mirror, I can call it maybe M1, is rotated or adjusted until the horizon H prime is seen to coincide with the horizon H. Is that okay? Until it is seen to coincide with the horizon H. Is that okay? So we are saying that we adjust this mirror here, not until from your observation of this side here, you see that the horizon of this level here, a reference object at this level, is seen to coincide in the same position, or is seen to be in the same position with this other horizon here, as you're seen from this side. Because now the rays from this other position, or whichever object which is this position that we're calling horizon H prime, the ray will come instead on this mirror here, and then reflected to this second one here, and then come this other side, you'll be seeing the horizon of this. And now in a scenario where it is seen to be in the same position with this horizon that you're seeing directly through this. Okay? This one here, you'll be seeing it directly through the unsilvered part, whereas this one will be seen after the successive reflection in these two mirrors here. If they are all seen to be in the same position, and then in that position there, the two mirrors are said to be in this situation that two mirrors are said to be parallel, and the position of the movable mirror noted as a M1. Is that okay? The position here is marked in a scenario where we are saying this horizon and this horizon, they are in the same position. We mark the position of that mirror M1. And then what do we do next after marking that? You say now, the movable mirror is now rotated to bring the image of the sun in view from the telescope. Is that okay? Then now in the next thing, after seeing this lower horizon is coinciding with the other one, the next thing is now to rotate this mirror here. Now again we bring now the image of the sun in view in our telescope here. But we should rotate it until it coincides still with this horizon here. Okay? So now the movable mirror is now rotated to bring the image of the sun in view from the telescope to be seen. Coinciding with the horizon H. Is that okay? And then you say the angle of rotation of the mirror is then determined. And then the angle of elevation is twice the angle of rotation of the mirror. Rotation of the mirror. Is that okay? So we are saying that it is now very clear that after rotating this mirror here through an angle theta, okay? After rotating it through an angle theta, and now it is very true that we have brought the view of the sun in our telescope here. That now the light ray is coming from it, incident on this, reflected here, and then reflected here. We are seeing the sun. At the same time, we are seeing this horizon in the same position there. In the same position. In that case, we are saying that we stop this mirror here in position M2 and measure the angle of rotation theta. Is that okay? So if we measure the angle of rotation theta, that means that the angle of elevation of the sun is twice this angle here. Why? Because we are saying that this is as a result of shifting this mirror from this position to this position. The light ray initially was in this position, but now it has been shifted here. So I could call this one as X, as the shift in the what? As the shift in the ray that is coming from these two objects. Initially it was here, and now it shifted, now it is in this position as a result of rotating the mirror through an angle theta. Therefore we shall say X equaling to twice theta. But don't forget, X is the angle of elevation of the mirror. Angle of elevation of the sun. Is that okay? Because you say if I have this and then the object is above, this angle here is what we are calling the angle of elevation. Is that okay? So X is the angle of elevation, but it is twice the angle of rotation of the mirror. So being in position of measuring the angle of rotation of the mirror, we can therefore say that we can also determine the angle of elevation of the sun. Is that okay? This is all about what we are calling a sextant. Is that okay? Don't forget, we say sextant operates on a principle that if we maintain the incident ray in the same position, but we only decide to rotate the mirror, what happens is that the reflected ray will shift through an angle which is twice the angle of rotation of the mirror. Is that okay? Maintaining the incident ray in the same position, by rotating the mirror makes the reflected ray to rotate through an angle which is twice the angle of elevation, the angle of rotation of the mirror. And we said one of the applications of that idea is in the sextant. And we said, what is the sextant then? We said the sextant is just a device that is used to determine the angle of elevation of heavenly bodies, e.g. the sun and the stars, isn't it? As an example of any heavenly body that we are talking about. Is that okay? And he said, what could be the parts of the structure of that very instrument you're calling a sextant? We say it consists of a fixed half silvered mirror, and this one here. Half of it is painted, half of it is left free, and it is fixed, does not move. And then we said also is having a fully silvered mirror which is free to rotate. And this is this mirror here. It can easily rotate. Is that okay? And then it also have the telescope where we make observation from. And this is now the drawing of what we are talking about. And we said, how does it operate? How does it perform its function? Is that okay? Modes of operation. We said number one, if you want to use it, like take an example, you want to determine the angle of elevation of the sun. What you do, number one, is you'll first set a horizon at your level of the telescope. Set a horizon, a reference point, and then set another reference point somewhere above. Now, what happens is make your observation from the telescope as you're rotating this mirror here. Not until the horizon that you have set above is seen to coincide with the horizon at the level of your telescope. As you're rotating, light rays will come from the horizon above, reflected here, and then reflected. That means you'll be seeing this horizon. And then this horizon here, you will be seeing it directly through the unsilvered part. Is that okay? So that means that you're in a position of seeing all the 2 points. As you are adjusting, you will adjust until all these two are seen to be overlapping or coinciding in the same position. In a scenario where that has happened, we are saying that what you do is you now mark the position of this mirror here. That is what we have written in this point here, okay? That in the situation where the two mirrors are said to be parallel, they are said to be parallel, and the position of the movable mirror is noted as M1, this position here. Is that okay? So after noting that now this mirror is in this position and you've seen all that, rotate it then from that position, okay? Such that you bring the view of the sun, okay, in your eye here as you're observing from the telescope. If you bring the view of the sun in your telescope now, in that the sun is seen to coincide with this lower horizon, okay? Now this one is already off now. You've brought in the sun. In that the light rays are coming here, reflected, you're seeing the sun. And then this one, you're seeing it directly and in the same position. What is very true there, we now measure the angle. You rotated it through which angle from the first position. In such a case that you are now bringing the sun in view. We measure that angle of rotation of the mirror, because now as you're rotating, this ray here will be shifting to bring the sun in this position as you're rotating this. So if I measure this, I will know that the shift in this ray here is twice the angle of rotation of the mirror. And we are saying that this angle here is what we are calling the angle of elevation of the what? Of the heavenly body we are calling it the sun. So having looked at that, let me meet in the next video, to look at also another instrument. Thank you.